Alright, so in this video we have an example where we have a square wire that has a width of 2 millimeters and a length of 5 meters. The current through the wire is 5 amps. You want to know what the current density of the wire is and what the electric field on the wire is. Alright, so current density is current per unit area. And since this is a square wire, the width is going to apply this way and this way. So I'm going to take 5 amps divided by length times width, which is going to be 2 times 10 to the minus 3 meters times 2 times 10 to the minus 3 meters. Alright, so that gives us a current density of 1.25 times 10 to the 6 amps per meter squared. In part B, we want to know what the electric field on the wire is that's causing that particular current density. So in order to do this, we need to use the relationship, so Ohm's law, the resistivity equals the electric field divided by the current density. Since this is a copper wire, I can look at the resistivity at room temperature for copper and plug in the current density I found in part A. So I get an electric field of 2.1 times 10 to the minus 2 newtons per coulomb.